Hi guys, welcome back to another episode on our A2 chapter 26, Rate Kinetics. So in this chapter, we're going to cover there's a few elements that is very crucial in this chapter. For example, you have to know how to identify the rate order, the order of reaction, and to understand what is the meaning of first order, zero order, second order. Then second thing is how do you construct your rate equation? That also know the difference between the half-life in knowing the difference between the half-life in first order reaction, zero order, and second order reaction. And also you must know how to construct your rate equation so to identify your rate determining step. So identifying your rate determining step is quite difficult, so especially when questions come up with like a different ions. Okay, so in the lesson, I've went through some example with you guys, so please go through it. At the same time, you need to know the mode of action of catalyst. Like a homogeneous catalyst, you don't need to know, but you need to know for heterogeneous catalysis, the mode of action. That is very important. Okay, and apart from it, Arrhenius equation is usually in paper 5, so it's not very important in your paper 4, but you still need to know how to attempt questions like that. And also the last one, you need to know how to construct your rate mechanism involving either an ions or involving a catalyst. Okay, and that's it. So without further ado, so please go through the entire recording. So please go through the entire video and try your best to do some topical questions here. And all the best, guys. Guys, again, for catalyst, right? Okay, the sequence is different. So again, catalyst, right? First step, yeah, catalyst is being consumed. Remember, okay, you must consume your catalyst first. And second step, okay, catalyst is being reformed. Understand? So catalyst is consumed in the first step and reformed in the second step. That's it. Okay, so guys, I will show you one example. Then you have another question. Then you guys show me the wait, where? Oh yeah, okay, good. I love it. Okay, now let's go. So kid, you see, right? I have this equation, CH3CO. This is a propanone, and plus I2, I get this thingy and HI. So the rate equation is given as shown. Okay, guys, do you see that out of nowhere, right? You have a H plus. Why? What is this? Why is there a H plus? Okay, reason being, right, this H plus is a catalyst. Okay, again, yeah, the H plus is a catalyst. Okay, now, guys, let's propose a two-step mechanism. Let's go for the first step. So, guys, for first step, right? Okay, so again, as what I mentioned, right, whenever a rate equation is given to you, try to use whatsoever that is given to you as your first step. So, guys, go. So I can say that a CH3 COCH3 plus a H plus. Do you see one more, one more? All right, guys, now please show me your BSQ. What do you guys want? It's time to BS again. Up to you guys lah. Anything. Yeah, memang it's really like that. What guys want? CH4. What is CH4? Then CH3COCH4 like that. All right, fine. Up to you. All right, guys. I put it as CH3COCH4 plus. Okay, that's my BS. So second step. All right, guys, can you complete the second step for me? Go. Okay, guys. Before we move on to the second step, this question is slightly different because you have a catalyst here. H plus is a catalyst here. Do you see that in the first step, my H plus is consumed? Will teacher please go up? Can I'm going up. Right? You see that your H plus is consumed in the first step. So guys, second step, yeah, my H plus must be reformed here. Understand? H plus must be reformed here. Okay, so I know that my product would definitely have one H plus. Go. Yes. USB-C. Plug.
2 seconds. This is disconnected.
Wait, I don't get it. That?
This is not connected now.
Shoot.
But I think I touched it. But it disconnected because I don't use it anymore.
So how does that it?
Just like a few seconds.
Not for a few seconds. USB-C. I only have this though.
Oh, yeah.
This one, right? But does it work?
Yeah.
It's that long though.
I think that.
No, let's go. That's fine. Hopefully it works out.
You.
Welcome. That long just to charge your pants.
This is disconnected.
How's it?
Okay.
It's connected now.
Oh, that's better.
It has battery? Good. Welcome. Okay. Hey guys, come. Got the answer. Anyone? Alright, so guys, I know that, right? My CH3CHCOCH4, right? This is our nonsense, right? We have to cut it out, yeah? And guys, you see, this already used up, right? So for my reactant, it's left with an I2, correct? So I can react with an I2. If I react with an I2, what do you get? CH3, COCH2I, and a HI, and a H plus. Okay, so guys, you see here, these are CH4. So get rid of 2 hydrogen, you get CH2I, HI, I plus. Done. So guys, when you try to add them up, right, what it will be? So guys, do you see that your H plus and H plus is cancelled out? Correct. And do you see your intermediate species is also cancelled out? Can see that? So guys, your final answer is just a CH3COCH3 plus I2 turns into a CH3COCH2I and a HI. Understand? Okay, kid, let's look at it, right? Okay, we have two different thingy that we cancel out. So one of it is a catalyst, another is an intermediate species. Okay, guys, please tell me which one is the catalyst? My catalyst is a H plus, right? Why? Guys, remember a catalyst, right? A form is being, okay, it's used first, then reform, right? Correct. So catalyst is always reform at the end. So you use it first, then reform at the end. What about intermediate species? Okay, what is the difference between intermediate species and catalyst? It's just the sequence. Okay, so intermediate species that we have here is a CH3COCH4 plus. Okay, that is our intermediate species. Why? Because it is formed first, then used, right? Understand? Okay, so again, yeah, guys, it's just the order. Catalyst is always used, then reform. Okay, then intermediate species form first, then use. That's it. Understand? All right, guys. Okay, I want you guys to try out page 21, donkey. Go up, kan? Alright, guys, I want a two-step mechanism, yeah? Okay. So, what's your two-step mechanism? I'm very curious. Okay, first, NO2 plus O2, right? Then NO2 plus O3. What do you guys want it to be? NO5. Okay. NO5, let's go. I mean, up to you. Like, I don't mind though. You want NO, NO2, NO3. Okay, up to you. Like, really, guys. All right, then after that, NO5 plus another NO2. Yeah. What the crazy? Can I have NO5? Oh my god. That's a bit crazy, bro. Okay, then plus O2, what do you get? You get N2O5 plus O2, right? Okay, so guys, I mean, this is okay. Okay, technically saying right, it's not wrong, but sometimes, okay, let's say if I'm being strict, right, then I might reject the answer. Reason being, right, nitrogen cannot fit five oxygen. Yeah. Reason being, okay, I mean your concept is correct, but okay, but in chemistry wise, right, nitrogen cannot have five oxygens surrounding it. So let's try to refine this answer. So maybe we can turn it into something else. Okay, so I can turn it into NO3 plus an O2 first. Okay, so I can turn it into NO3 plus O2. I think this looks okay, right? Okay, this looks more acceptable, at least not that triggering. NO5, right? Wow! Okay, so I have NO3, okay, plus another NO2. So turn it to an N2O5. That's it. Okay, easy, right? Good. Yes. And what? And
Is this
free radical.
radical?
Free radical and.
The free radical. So it's like
I mean, okay, again, right? If you write that, right, I mean, can but try not to write it in your actual exam. So in your actual, I mean, like you can frighten your school teacher, go and frighten your school teacher, yeah, just go and trigger him. But in actual exam, try to write something that makes sense. Okay, so try not to free radical too much. I mean, it's acceptable, but I don't know, maybe the examiner after like 100 paper, everyone give a standard answer. Suddenly you come in with a free radical. Then it's like, oh my god. All right, guys, now, okay, what do we have? It's Arrhenius equation. Okay, so guys, again, the Arrhenius equation is the most PS. Okay, because I never seen this in P4. I know, I hardly see this in P4, like never. Maybe P5, just once in a while, a P5 question will have this. And again, right, you do not even need to memorize the formula. It's given. Okay, the best part is it's given. Okay, so Arrhenius equation, right, the only thing that you need to know is to plot the graph. Okay, so guys, you see, right? Okay, I know that this is my rate equation, correct? Rate equals to K, concentration of A, concentration of B. So guys, I know when I increase concentration of A, my rate increases, correct? But guys, okay, generally saying, when temperature increases, my rate also increase, right? But there's no function of temperature here. Why? Okay, because temperature, right, is K is a function of temperature and pressure and also a catalyst. So basically K, okay, has temperature, pressure, catalyst, everything summarized into just one unit of K. Okay, so I can mention that, right? The temperature and catalyst can change. Okay, rate of reaction, but do not fit into the rate equation. Why? Because this is included in your K, a rate constant. Okay, so your K, right, is a function of temperature. Okay, it's a function of pressure. It's also a function of catalyst. This is shown in your Arrhenius equation, guys. Okay, your value for K, right? I can write down A equals to AE negative EA over RT. Okay, so K is your rate constant. A, right, we call it as frequency factor. EA, activation energy. Okay, R is our gas constant. T, temperature in Kelvin. Right, guys, I'm sending a paper over to the group. So you guys can download this paper. We're going to go through some of the questions. All right, guys, now, okay, so A is a term, right, which includes factor like frequency of collision. Okay, so you may also come across a different kind. Okay, guys, now in exam, right, usually your K, right, okay, I can derive it. So K equals to AE negative EA over RT, right? Okay, sometimes you might need to know how to derive it in exam. Yeah? So, guys, I can log both sides. If I log both sides, what do you get? Log A, E negative EA over RT, right? And guys, after that, in logarithm, multiply is plus, correct? Log A plus log negative E, log E negative EA over RT. All right, guys, next, I can apply the power rule in logarithm, power rule. I can bring down the power as multiplied, correct? Okay, and guys, what is log E? If you press in your calculator, log E is just 1, yeah? So I can say that log K equals to negative EA over RT plus log A. So guys, I'm gonna summarize it in, okay, I'm gonna simplify it even further. So guys, can I say that log K equals to negative EA over R multiplied by 1 over T plus log A? Okay, that's a new form. Okay, that's another form of your Arrhenius equation. All right, guys, after this, next page. So Arrhenius equation, right, can always be drawn on the straight line. Why? Guys, this is my Arrhenius equation, right? If you linearize, this equation is already linearized. Can you see that y equals to mx plus c? Your gradient is just negative EA over R. Your y-intercept is just log A. Am I right? Good job. All right, guys. Okay, I have a question at the bottom, and I want you guys to find out what is my E and what is my EA and what is my activity factor. Go. Let's try the next question. It's math. So, guys, to get your gradient right, I can just randomly pick 2 points here. So maybe I can pick the top, the uppermost, and the lowermost. Pick these two. So how to get your gradient? Your gradient is just equals to negative 1.3 minus is a plus over 0.00143 minus graph. How much is it? I'm getting around negative 3015.8. That's the gradient, right? Okay, then guys, how to get your EA? Gradient is equals to negative EA over R, right? Okay, so EA is equals to negative MR, correct? Is your answer 25,061 joule or 25.1 kilojoule per mole? That's it. Alright, guys, after you get your EA, can you get your frequency factor? So I can pick any points, again, because I do not have the y-intercept, right? So I have to submit already. Maybe I pick the middle one now this time. So I know that my point is at okay. Negative EA over R is gradient, right? So I'm just gonna plug in negative 3018.5 multiplied by 0.002 plus log A. What's log A equals to? It's just match, right? Okay, 3.0116. A is 20.3, right? Okay, so guys, again, your answer given it will be a range. Okay, it's need not to be the same as my answer, but as long as it's within the range, then it's okay. Oh, good. Alright, guys, once done, let's move on. Okay, this is the last part already. Alright, guys, see. Okay, so guys, we have catalysis again. What's catalysis? It's just catalyst, basically. So guys, we have different type of catalysis. We have homogeneous catalysis. What is homogeneous again? Same physical state, right? Same phase, right? Okay, so example, we have iodine peroxide disulfide reaction. Okay, and I can say that, right? Okay, this reaction is catalyzed by Fe3 plus. Okay, and guys, let's go. Do you have the rate equation? No, I don't have the. Okay, since I do not have the rate equation, it's fine. So, guys, I'm gonna give you the equation. I want you guys to complete it. So first, right, I have Fe3 plus I minus. Put 2I minus first. Alright, guys. Now I want you guys to complete the entire. Okay, I want it to be two step, and I want opposite charge ion to react. Yeah, that's it. Okay, so guys, please get the final answer in two step. Oh my god, forgot to give the charge. S2O8 2 minus. You should have a 2 minus here, or else it's not balanced. Please change it to S2O8 2 minus. Alright, so what do you got? So I can turn the I into I2. So I have to maintain the charge, right? So 3 plus 2 minus is going to be 1 plus, am I right? Okay, so please maintain the charge. Second step, Fe plus S2O8 2 minus what turns into 2SO4 2 minus Fe3 plus. Check the charge. 2 minus 1 plus is minus 1, correct? 4 minus 3 plus is also minus 1. Hold on. That's it. So guys, do you see that this is acting as a catalyst? Alright, right. Right, by intermediate species. Fe plus is by intermediate species, right? Understand? Good. Yes. FeI2 plus. Can? It's okay. FeI2 plus is good. Yeah, and it makes sense because iron can, yeah, iron indeed can bond with two iodine, no problem. Yeah, FeI2 plus is good. Okay, guys, next. Okay, guys, again, we have oxides of nitrogen in acid rain. Yeah. So, guys, I'm going to give you the first step. I want you guys to complete it. I want you guys to do it in two steps. Yeah. First step, NO2 plus SO2. And guys, highlight the word reaction is catalyzed by NO2. So which means my NO2 must be reformed. Right? I give you another condition so everyone will get a similar answer. My intermediate species is NO. Okay, NO is my intermediate species and two-step reaction. Let's go. Alright, guys, what's your answer? 10 2? Okay, the standard one. Okay, then after that, second step. Yes, NO plus half O2. Yeah, well done. Okay, so everyone must get this answer. There's no alternative. Okay, so there's no alternative because I get you some condition. So if you follow all the condition, there's no alternative. Okay, easy, okay, so good with your BS mechanism. Now, okay, so we are done with homo. Let's look at hetero. So guys, for hetero, right, it's when the catalyst is in a different phase here. Okay, it's in a different phase. So guys, a good example is in the catalytic converter. What do we have? We have platinum, we have rhodium, we also have palladium. All right, guys, basically for your hetero catalysis, right, the mechanism, OMG, guys, the catalysis, the mechanism, you need to know it. Okay, so it might come out as a 3-mark question as, okay, in your exam to explain on the mechanism. So again, guys, at first, right, all the reactants are highlight the word chemically adsorbed on the active site. Adsorb. ADSORBED. Adsorb. Okay, chemically adsorb. So guys, what is the meaning of adsorb, right? Adsorb is a surface reaction. It's a surface reaction between gas and solid. Okay, so not absorb. Yeah, absorb means goes inside. No, adsorb means the reaction happens on the surface between the solid and a gas. Okay, then the bonds formed on the surface ion and the reactant breaks. Reactant, yeah, breaks the covalent bond. Okay, highlight the word bonds formed and bond break at the same time. Okay, so bond is broken, bond is formed at the same time. And once you get the product right, then the product will desorb from the surface. Desorb means go away. Okay, and react again on the surface to form ammonia. That's it. Good. Alright, guys. Now, I'm not gonna do the next part. So next time, I think we'll repeat before exam. So the next part is you don't really need to know. Now, I want you guys to download the past paper I have. Okay, I sent it to the group, and I want you guys to do some questions with me together. Yeah. Okay, let me send it to you guys. Yeah, you just want your airdrop, then I drop it to you. It's A2023. Let me check the paper again. ON43. Oh damn, I do not have the paper. How? What? Cannot be. 2023 ON43. Okay. A second here, guys. Yeah. Này, you can add on your airdrop. Yay. Gasan! Bro, I like the name, bro.
Year 5.
Alright, guys. First question, yeah. First question on the paper, it's already a bullshit question. So this paper start with a bullshit. Let's go. Let's PS it together. Go. This question the same as same as 4-1, no wonder. Okay, now we do it again. Alright, guys, highlight this here. First order with respect to F2, first order with respect to ClO2 here. So I know that my rate is KF2 ClO2 here, which means first step, okay, any of your steps should have one F2 and one ClO2. So guys, my first step must be F2 plus ClO2, yeah. Hey, wait, what? Hey, Emma, you're not in my room, eh? Are you serious? They are not at you? What? Alamak, why ah? Okay, let's go. Come, Jonas, what's your answer? Let's go, impress me.
F2CL2.
F2CL2. F2ClO2. Oh, everything combined. Okay. Another ClO, right? And turns into 2F ClO2. Right. Yeah, guys, that yeah, that is acceptable, of course. Yeah, just combine. Well done, guys. Guys, which one's your rate determining step? Explain your answer. Step 1, right? Well done. Why is it so? Because it has one more of F2 and ClO2 reacts together, right? Alright, guys, complete the rate equation. Lol, I already have the answer here, right? KF2CL2, am I right? Guys, what's the overall rate? So overall order is a 2, right? Well done. Okay, guys, next. Let's identify the rate. Just press calculator, this one. Not 2, right? 1.22, right? $4.88 comes out about -6. Is that right? So guys, you see, it's super easy, right? In Rate Kinetics, it's a honeymoon chapter, guys. It's really very honeymoon. That's it. You score all the points. Okay, guys, next question, right? Also not hard. Maybe the bottom graph is hard. Okay, guys, now let's try. All right, guys, you see, right? Calculate the numerical value for K. So, guys, I introduce you guys a formula, right? You see that this is a first order. Am I right? So, guys, what did I mention about first order? Half-life? Yeah, log 2 over something, right? Half-life is the same, right? Remember that? So, my half-life is log 2 over K. Well done. Okay, it's log 2 over half-life. What's your half-life again? 4, right? Final answer? 173. Guys, what's the unit? Per second, well done. Because log 2 has no unit, right? 4 seconds, right? That's it. Okay, again, 3 marks. Like that, 2 marks. Crazy. But if you forget the formula, then ha. Right, guys, now, plot the graph, give me the rate. Let's go. This is so easy. Guys, remember what I mentioned about first order, yeah? I want you guys to do first. I will discuss. Guys, let me highlight all the keyword needed. Half-life is 4 seconds. First thing. Starting concentration 0.02 second. That's it. This is so physics. Starting 0.02. Draw across. That's it, guys. Recall what is half-life. Guys, what is half-life? Time taken for the original value to drop to half, right? Well done. So every 4 seconds will half, yeah, go. And you have to tell me, will it be a curve or will it be a straight line? So 0.02, after that drop to 0.01, right? At 4 seconds, correct? So 8 seconds is going to be 0.05, right? 12 seconds, 0.025. Well, where's 25? 25 is slightly above, like here, maybe. Okay, guys, let's draw a sexy curve here. I want you guys to draw a curve, okay? Alright. Yeah. Oh my god, so smooth. Sexy. Alright, guys, next. Wait. Guys, This is a concentration versus time graph. How to get the rate of reaction? Tangent gradient. Thank you so much. Let's go. Tangent gradient, get the answer, and 1 mark. See guys, 9 mark. You can score, right? Not too bad, right? Yeah. So this chapter is really, you must score every single thing. It's not hard at all. This chapter is the easiest. So guys, take a ruler, draw tangent gradient. Now I'm going to take the first point as 0, 16. The second point as 10.5 and 0. Is that 10.5? No. 10.6 and 0. Okay, guys, my answer is about 1.51 times 10 to the power of -4. Guys, don't care about the negative here. The negative is indicating the reactant is decreasing. The rate is always positive. All good. So, guys, you see, right? If the graph is wrong, the bottom one is wrong. Okay, but it's not too bad. This is quite easy to sketch. Okay, guys, after this question, I want you guys to skip 2, look at 3. Okay, 3 is also a recent chapter that we have done. Entropy, entropy is also a honeymoon chapter. It's also maths. By the way, we are done with all the. Okay, so for my major kid, right, we are done with all the honeymoon chapter. So basically, there's no more honeymoon chapter left. No, there's another one, chapter 2. So after that, it's gonna be all the hard chapter remaining. What you guys are doing now is good. Sorry? I see the other guy. PH. GG. That's the hardest. What were you guys? Yeah! I'm faster still. Let's go. It's okay.
Even more.
Even more.
Yeah.
I mean, like your teacher also, but your mock exam, it's gonna, when is it?
Oh, definitely.
That's why. What about you guys? No mocks also. January or January.
Oh, I think we have more, but then for certain subjects.
Certain subjects, not for chemistry. But why not for chemistry?
No.
Interesting.
Yeah.
Oh yeah, true. But yeah, mock exam is also like what for, right? You guys are already using your AS to apply anyway. Yeah. So mock exam for A2 is like, woo! Yeah. Alright guys, let's go. Okay guys, what is entropy again? What did I mention last time? How? Disorder, the degree of randomness of a system, right? Okay, good job. Okay, so I can mention that it's a degree of randomness, or you can mention a disorder in a system. Done. Super easy. All right, guys, entropy for reaction 1, is it positive or negative? Let's recap a bit. I will teach you guys. Yeah, but we do it together. Let's recap. Is it more disorder or less disorder? More, right? Why? You see a gas form. So the sign is positive, right? Guys, there's two different reasons. One is a gaseous product is formed. What else? Can you give me another one? There's two factors affecting the moles, right? So do you see that from 2 moles to 3 mole, right? So from 2 mole to 3 moles, right? Done. Easy. Alright, guys. Next, one energy. So familiar, right? So AS, right? Let's go, boys. These are all the honeymoon chapter, yeah, guys. You see, honeymoon chapter, you must score it. Use the data to show that the enthalpy change of the following reaction is negative 196. So, guys, H2O2, right? That's not something like that, yeah. Alright, that's a H2O2. So, guys, please work it out. What's my BB? My BB, I have 1 mole of OO, which is 150, and 2 mole of OH, which is 2 times 460. Total answer, wee! 150, 2 times 460, 1070. Is that right? That's your BB, yeah? Alright, guys, next, what about my BF? So, guys, I hope you guys know. Okay, so basically, I have 4 mole of OH, because 1, 2, 3, 4. Okay, so which is 4 times 460 plus 1 mole of O double bond O, 496. 2336. Hey, what's so big one? Oh my god, I forgot to multiply the value by 2. Lol. 2 here and 4 here, right? Funny, 1070 times 2, 2140. So my delta H is equals to BB minus BF. 2140 minus 2336. Answer? Negative 196 kilojoule per mole. Yay, feel so AS. In AS, right, this is gonna score you maybe 3 marks or 2 marks. Sorry, 1 mark only. Because it's very easy. Alright, guys, next question. Let's go. Okay, next question. You need to recall our formula. Yeah. Oh no. Oh yeah, you need. So guys, I'm gonna give you the formula. I want you guys to work it out. The formula is delta G equals to delta H minus T delta S. Alright, guys, again, your T delta S, you have to convert to what? To kilojoule, yeah. Remember, because delta G is given in kilojoule, yeah. Please work it out. Okay. So guys, again, my first step, right, involves finding delta S. How to find delta S? Formula delta H minus T delta S. Is that right? So guys, can I say that T delta S equals to delta H minus delta G? Can I say that delta S equals to delta H minus delta G divided by T? Can I write? Let's plug it in. Negative 196 minus 238 over, what's the temperature again? Am I blind? Oh my god, up there. 200, 198. Okay, guys, your answer here, yeah, is given as kilojoule. Okay, so guys, second, can you convert into joule? Okay, so I get it as 141 joule per mole per Kelvin, right? Does that, can you apply the formula for delta S? S product minus S reactant, right? S product is how much? O2, 2H2O, 2 times 70, minus S reactant, 2 times 1O2, right? 141 plus 2 times 102 minus 2 times 70. Your answer is 205, is that right? Done. Okay, 3 start. 3 mark. Where did 102 come from? Okay? H2O.
Oh,
Right? Yeah, that's your reactor, right?
oh, okay.
Okay? Alright, guys, next. The decomposition of H2O2 is catalyzed by aqueous iron 3 chloride and by silver metal. Which of these two catalysts is acting as homogeneous? So guys, let's go. Which one is homogeneous catalyst? H2O2 aqueous, iron 3 chloride, right? Explanation. Same phase as H2O2 reactant, right? Done. Right, not too bad, right? So your A2 paper is actually pretty okay, right? Not too bad, right? Because all these are the honeymoon chapter. I haven't teach yet. Yes, crazy. Let's go. Alright, guys, what's hydration again? Okay, do you still remember what is hydration? Enthalpy change? What's hydration, guys? When one mole of gaseous ion dissolve in water, forming aqueous solution, right? That's it. Yay. Alright, guys. Let's go. Next one. Alright, guys. How's it? Forgot. It's okay. Okay, guys. Hopefully, we're going to start from the easiest one. Guys, should remember what is lattice. For example, if you want to get AlF3, right? Guys, lattice is from what? Gaseous ion, right? So it's Al3 plus gas, that 3F minus gas, right? So guys, maybe I can, which one you guys want to put it? I think I start with this one first. So Al3 plus gas can 3F minus gas can turn into AlF3. Solid, yeah? Die. GG. Cannot. Because I have this arrow. And this arrow cannot be it will never, so hydration and your solution would not form a solid. So I need to put this here. Put this here first. Yeah, that it makes sense. So this is a delta H naught lattice. Alright, then I can play around. I fix it first. Hey, bruh. Alright, guys, next we have solution and hydration. Alright, guys, again, what is solution? Please tell me. Still remember what is solution? Alright, it's okay. I give you a quick recap. Alright, guys, solution is super easy. Okay, solution is basically from a solid turns into what? Aqueous. Let's see that, guys. Solution from a solid turns into aqueous. From a solid turns into aqueous. Or if you want to write it separately, yes, you can. You can turn it into these two aqueous. Asad, guys, can you fill your solution there? Go. Where's the solution? Can I say that going this to here, that's the solution? Am I right? Alright, guys, finally, what is hydration? I get you the definition for hydration already. What's hydration? It's 1 mole of gaseous ion dissolved in water, forming aqueous, right? You see gaseous turn into aqueous. That's a hydration, right? Done. Understand, guys? So far, so good. Can? Alright, 3 bucks. Right, guys? Apply the hash law, get me the final answer. So early? Holiday Oh yeah, bye-bye, see ya. There's many ways to order. Yes, correct. There's many ways to draw this. You are right. My answer is just one of the possibility. A bit different. Yeah, it's just one of the possibility. Alright, guys, got this. What's your answer? So, guys, according to your Hash-Law cycle, right? Hydration equals to lattice plus solution, right? So, guys, what's my hydration? My hydration is of Al is -4690. But don't forget you have 3f minus r, guys. Remember to multiply this value by 3, yeah? Equals to, what's my lattice? I just put it as delta H lat lah. Solution, negative 209, right? Guys, what's my delta H lat? Negative 5999. Sexy value. I love it. Okay. Hannah. Good, right? Okay. Yay. Okay, so guys, that will be all for the class today. Next week, we will do another recap. Okay, before we move on to a new chapter, yeah. Okay, so I'm taking it very slow, don't worry. Okay, so I'm taking it super slow. Yeah, very slow also. Okay, so that's all for class today. Oh, by the way, there's no physical class next week because we are on the Deepawali holiday. Okay. So see ya. Bye bye. Cheers.
Please like and subscribe. Please like and subscribe.